Hi everything!
Today I will introduce to you systems of linear equations in three variables. Let's go back to when we were Form 1. As you can see, this is two linear equations in two variables. But this time, instead of two variables, we will have three. And that's what we're going to learn today in this video. Before we do any calculations, let's understand the concept first. This is a graph with two linear equations in two variables. As you can see, this graph is two-dimensional. While in three variables, we will have a new axis, which is z-axis, which makes it a three-dimensional graph, and it's called a plane. So the equation to draw that graph, that plane, is this. Now, simultaneous linear equations in two variables has two equations, right? The difference is that systems of linear equations in three variables have three equations, as you can see. The reason being is to accommodate the three variables so that we can find the value of all variables. These are the types of solutions that you will see throughout the series of video. We have one solution, infinite solution, and no solution. Please pause if you need to read further. That'll be all. Thanks. Okay guys, today I will solve question 1. First, let's see the question in the video. To solve this question, we can use the elimination method. First, we need to label the equation for reference. Next, we eliminate equation 1 and equation 2. Then we will get a new equation, equation 4. And next, we do the same thing for equation 1 and 3, and you will get equation 5. Do pause if you need to. Hence, we will get two new equations, 4 and 5. Thus, by using elimination method, we eliminate both equations, and then the final equation will be a contradiction, which means that the question has no solution. To prove to you, let's use GeoGebra 3D graphing calculator. As you can see at the graph. At a closer look, you can see that there is no point of intersection for all planes. Here is a closer look if you want to see.
Let's look at the question. Label 1, 2, and 3 as each equation. Next, eliminate equation 1 and equation 3. But first, multiply equation 1 with 2. To make the values of h and k same with the values in equation 3. And you will get negative 7j equals to negative 8. Now, let's use equation 3 and equation 2. Multiply equation 3 with 2. And you will get this answer.
Hi guys, today we are going to solve question 3. So the question is on the screen. First, we need to label equation 1, 2, and 3. Then equation 1 is added with the equation 3. So you can get the answer. The answer is equation 4. I will write it on the top so I can use it later. Then, equation 2 is added with equation 3 that is multiplied with 2. So you can get the answer. It will be equation 5. Equation 4 and 5 is used right now. So equation 4 that is multiplied with negative 3 is added with equation 5. So I will get 0 equal to 0. 0 equal to 0 means there is infinite solution to the system. I will show you a graph of infinite solution using 3D graph calculator. As you can see, when I turn the graph, you can see there is many intersecting points on three planes. It shows us that the linear equation has many solutions. That's why it is called infinitely many solutions. Thank you. That's all.
Assalamualaikum, and today we're going to solve question 4. So first, let's look at the question. And in this question, we can solve it by using the elimination method. So first step to take is to label the equation as equation 1, 2, and 3. Next, choose two equations it has the same variables that are easy to eliminate. In this question, I am going to use equation 1 and equation 3 to eliminate r. I'm going to time equation 1 by -1 so that we could eliminate r. Then we will get a new equation, which is equation 4. Then we take a new equation to eliminate r again. I am taking equation 1 and equation 2. So first times equation 1 by -2 so that we could eliminate r. And we will get a new equation, which is equation 5. And the final step to take is to eliminate equation 4 and equation 5. So when we eliminate, we will get 0 equals to 0. This means that the system has infinite solution. To prove it to you, I am going to use a 3D graph calculator to show you how it looks. As you can see, the plane overlaps at one lane, thus the graph has infinite solution.